Hi, this is the first page of our new topic, which is I/O, input, output. And our first section is memory mapped I/O. And you're going to need this for lab 2, which you'll be demoing around week 6, I believe. So let's just draw a picture of a computer system. So we've got a processor. Just going to shorten that to proc there. And then you're going to have a couple of memories. So let's call this memory 1. So in the LPC 1768, you've got a flash memory, so maybe that's memory 1. And you've got SRAM memory, so say that's memory 2. I'm going to leave out the ROM, but that would also be here. And then you've got peripheral devices. So I'm just going to call this IO1, IO2, and so let's have an IO3. So here is our bus, and the processor connects to it, the memories connect to it. I've got lines going in and out of each because the data can flow both directions. It's usually the case for I/O devices as well. And so they're all sharing one bus, which means that when the processor outputs an address onto the address lines of the bus, the various memories and I/O devices have to look at that address and determine if that address corresponds to their range of addresses. Further back in time, there used to be at least 2 buses, a memory bus, and you'd probably have one memory attached to that bus, and all the addresses on that bus were memory addresses. And then you'd have an I/O bus, and the I/O devices would connect to that. And all the addresses on the I/O bus were for various I/O devices. But then they just started integrating them onto one system bus. The Intel x86 instruction set still has I/O bus instructions, I believe, in its instruction set, but you're not going to see them used these days. So it's called memory mapped when I/O devices occupy some part of the address range on the system bus. So let's look at the LPC 1768. That is our MCU, microcontroller unit. So this is the LPC 1768 memory map. Let's just write some address ranges. So from address, these are all going to be 8 hex-digit addresses. So address 0 up to address 0007FFF. That is for the flash memory. So address 1, address 2, address 3, those are all addresses inside the flash, so you can read instructions or read-only data out of there. This is the instruction memory. And next, we skip some addresses, and they're unused addresses in this particular MCU. So if you try to address them, the bus read or write from the processor would time out, and you get a bus error, and your program would probably terminate. So from address 10 million hex, so I've got 8 zeros after that, so that would be 10 million. We'll just call it that for ease of reference. To 10,007,000 FFF. Those range of addresses are for the SRAM, and that is our data memory. It's read-writable. Okay, and then there's another gap in the addresses, so I'll leave another blank line there from address 1FFF0000 to address 1FFF whoops, too many F's there. I like to leave a gap in between each of the 4 digits just for readability's sake. I don't know how readable these F's are, but that's what they are. This is where the ROM memory is, and it's got some pre-installed factory code in it that we don't use. And then I'm not showing you all the contents of the memory map for this MCU, but we have, just to save space, I'm not going to skip all these lines. From address 20 million, whatever, 20090000, add a 40 there, to 2009FFFF. That is for the general purpose I/O. General purpose I/O. So you can connect things like LEDs and joysticks and that kind of stuff up to the general purpose I/O registers. That's how they're connected up on the board, the development board that we simulate, the MCB 1700. And further on in the address space, at address 4000C000 to address 4000 to C030, that is where your zeros registers are located. And so it's you should recognize that name by now. It's one of the 4 serial ports that are part of this chip. And one more. So address 50 million to address 50000FF4. That is the range of addresses for the registers for the Ethernet controller. So up here where I left space, there are some unused addresses between that first range and the second range, and likewise between the second and the third ranges. If you want to see the whole address map, you can look at the PC 1768 reference manual that has been posted on Learn. So if you send data to address 0, if you read at address 0, you're going to read the flash memory. If you read at address 4000C000, you're reading a register on the serial ports interface.